Number 6. The sum of 3 consecutive... Whoops, I'm reading the wrong one. Number 5. The sum of 3 consecutive numbers is 87. What is the smallest of the 3 numbers? Now, there's a lot of vocabulary that might be new to you. You should know what sum means. What is sum? Addition. Okay. So sum means addition. So we're adding. We're adding 3 consecutive numbers. Now, consecutive. Does anybody know what consecutive numbers mean? Okay. So, new vocabulary word for you. So, consecutive numbers mean numbers that come one right after the other. For example, 5, 6, and 7. Those are consecutive numbers. 5, 6, and 7. Who can tell me another set of consecutive numbers? 3 numbers that are consecutive. Yes. 11, 12, 13. 9, 10, 11. Are there like a million thousand? Yes. So, consecutive numbers, all that means is they come right after one another. Does that make sense? Okay. So, I'm looking for 3 numbers that add to 87. Okay? So, I'm looking for, I'm going to write this down. I'm looking for 3 numbers that equal 87. Basically, that's what the question's asking you to do. What 3 numbers, Samantha, look, I wrote this down. What 3 numbers equal 87? And they have to be consecutive. What does consecutive mean? One right after the other. I gave you the example of 5, 6, 7. A couple of you gave me different examples. So, what 3 numbers consecutive add to 87? Yes?
Do they all have to be different numbers?
It has to be consecutive numbers, which means one right after the other. So like 10, 11, 12. For example, and it has to be in order. For example, if I use 3, 4, and 5, what's 3 plus 4 plus 5? 12. So that means the sum of these 3 consecutive numbers is 12. Does everybody understand what we're trying to solve for? We're trying to solve for 3 numbers that you add them together and they get 87. And it has to be in order. Okay? It has to be one number right after the other. It's like a challenge. It's like a riddle, a puzzle. Like what 3 numbers, they come right after the other, gives you 87. What are you thinking? What do you think we have to do? We have to write an equation, right? But 40, 40, and 40 are not 3 consecutive numbers. It would be 40, 41, 42.
If we add those 2, they're gonna pass over.
Right.
It's like odd or even though.
It's consecutive. So it's like 3, 4, 5. 11, 12, 13. It could be 2 odds and an even, or it could be 2 evens and 1 odd.
Does it have...
Yes?
It has to be one number over.
What do you mean?
Or can it just be like... So here's an example, like 12, and then go to like 14.
No, it has to be consecutive. So it'll be, if you want to use 12, that's to be 12, 13, 14. Linda first, and we'll go to Gabriela. Okay. What are your numbers?
10.
How did you get those? I don't know if you're right or wrong, but how did you get those numbers?
Well, I was like, going down the number line, I was adding 3 numbers each, and then when I went to 28, 29, and 30, it added to each.
Okay. Gabriela?
The same number.
How did you get them?
I was just adding random numbers.
Adding random numbers. Okay. So, I'm going to let you in on a little secret. So, the numbers are, what were they again? 28, 29, and 30. But, are we just going to assume like, okay, that's it. I'm done. No, because what's the one thing they want you to do? What's the one thing we've been always writing in this worksheet? The equation. Do we always care just about the answer? No, we're caring about the equation. Cool. So this is something that students do. They come up with the answer, and then they work backwards. So here's my answer. Now, how do I translate this into an equation? Because once you get the equation, then you can always use it for other problems. What do equations always have?
X.
X. Right? X are always there.
3x equals 87.
Well, if we get 3x equals 87, then that means you're only getting the same number, not consecutive. Right? So, let's make 28 the x. Right? So 28 goes in this spot. How would I represent 29? Now, have you learned in 7th grade how to add and solve for equations that have different variables? Not in 7th grade. In 7th grade, we've only learned how to solve for one equation, right? X, usually x. Even if they're on different sides, even if we have to use distributive property, we've always just used one variable, correct? This, you'll do high school. So it can't be this. So how do I use the same variable? Well, we have to use the same variable. But these numbers are not the same. If I do x plus x plus x, that means it's 28 plus 28 plus 28. But I don't want a 28 here. I want a 29. So how do I make this be really equal to 29? I can't use a different variable. Yes? Not x2. X squared would make 20, it would be 28 times 28. That would be a ginormous number. Yes? Because what is x? X is 28. What if I do 28 plus 1? What do I get? 29. How do I get to 30? So,
You write in.
sometimes, when I know I'm going to erase at the end, yes. Okay. What does this simplify down to? How many total x's do I have? 3x plus
3.
equals,
87.
solve it.